Hey, physical science students. This is Mr. Olive, and this is going to be your second lesson. After Mr. Flugum's for lesson one, this is the law of conservation of energy. Law of conservation of energy just basically states that energy changes forms. It's never created or never destroyed. It kind of sounds familiar. You guys talked about some other laws before, and same terminology. We're going to just go over real quick some of the different types of energy that Mr. Flugum discussed on this next slide. So here's some examples. These are both examples of chemical potential energy. One form we'd put in our mouth, food, and the other one we'd put in a car. But those are both examples of chemical potential energy. I put CPE down there just to symbolize chemical potential energy, but you could write it out. We convert electrical energy to mechanical energy in these cases, and then eventually to thermal energy. So for like a toaster oven or a hair dryer, this guy obviously needs a hair dryer, but also the hair dryer generates sound energy. So just different types of energy. Never created, never destroyed, just transformed. Some of the types of energy you want to be familiar with, and we'll talk about, and we'll talk about in the next couple of units. Thermal energy, which could be caused by friction, like if I just rub my arm real fast, that could cause thermal energy, heat energy. Sound energy, potential energy, kinetic energy, that's energy associated with motion. Potential energy has different types Mr. Flugum talked about, like elastic potential energy. If I were drawing back a string on a bow and arrow or a slingshot, the surgical tubing on the slingshot. Mechanical energy, making something move, and chemical energy, like the food we eat. And just a reminder that the units for energy are joules. But under no circumstances will energy be created or destroyed. So it's always just going to be transformed. Okay, so let's take a second. Let's look at this guy right here in the half pipe, and let's look at all the different types of energy that we can think of just within this scene. You have this guy up here, pretty high. He's got high potential energy. So does he. He's about to head back down, and as he heads back down, his potential energy is going to decrease. His kinetic energy, the energy associated with motion as he speeds up, is going to go up. So those two are inversely related, and his wheels will meet the ground, which will cause friction, thermal energy. His hair will blow around, and that's more friction, air resistance. So this is just a review. If you were to look at every type of energy within the system, this is just a review, and you can pause on this for a second and look at this. Okay, GPE stands for gravitational potential energy. And you'll be asked to look at a system and just kind of describe all the different types of energy within that system. I do that here with this this scene right here. We've got a roller coaster. So when would you have high kinetic energy, energy of motion? When would you have high potential energy, potential for energy? Mechanical energy, something's making it go up. And the thermal energy, why would you need to really make sure that you grease the chains on a roller coaster? And when you take in calories, where do they go? If you're a mammal, most of them go to keeping your body at 37 degrees Celsius. So if you're a reptile, not so much. So reptiles' body temperature just depends on the how warm the sunny day is. In this particular example, we've got a hydroelectric dam. The hydroelectric dam stores up huge reserves of potential energy on the upstream side. It allows that water to go through little holes, not little holes, big holes, spinning turbines, and those turbines send electrical energy that we can turn into mechanical energy and thermal energy and all those things. One of our biggest exports is electricity from the Columbia River, same with Washington. So. If you look at combustible engine, the one that's been around since the early 1900s, little explosions that happen inside of cylinders. And the question is, where does the part that doesn't result in kinetic energy, where does it go? So it's not a very efficient tool, but it's one that we rely on a lot. So you've got heat, thermal energy here for the radiator showing, and pollution going out the back end. So this is another form, the uneven heating and cooling of our atmosphere, and just different ways that we take advantage of that, turn that into kinetic energy, mechanical energy, the windmill that's grinding wheat into flour. And then you've got selling across the Atlantic. Condon, Oregon, the windmill farms that are wind farms that are creating a lot of electricity. It's a big source of the sun's energy. That's I guess the primary source of all of our energy that we have, that eventually or originally it comes from the sun. So, and we're getting better and better at harnessing that. We just have to figure out how to quit tapping sources of energy that have tremendous downsides, and figuring out different ways to get things done, to get mechanical energy done, and to do work. All right, the next 6 slides have questions that I'd like you to answer. Some of the questions are going to be easy. Some of them are going to be kind of hard, and some of them are very hard. You get to pick the question that you want to answer. So they're all worth the same points. You just, how much you want to challenge yourself. And then you'll put your answers on a Google slide, and you'll share that with either me, Mr. Marquis, or Mr. Flugum. All right, here's question number 1. What is your first and last name? So you're going to put number 1 in your name, and then we're going to move on to number 2. Second question. So as this paratrooper descends to the ground, what type of energy is slowing him down? That's question number, your first option. As he heads towards the ground, what type of energy is slowing him down? Option number 2, you can answer this one if you wish. Describe using symbols or the words like potential energy, kinetic energy, thermal energy, or sound energy. Every type of energy that this guy experiences from the time he leaves the plane until the time he hits the ground. That's option 2. Option 3, a little bit trickier. If you've seen Band of Brothers, that series, a great series, this will be familiar to you. Before the 82nd Airborne was dropped behind enemy lines in France on D-Day, the paratroopers were surprised with over 100 pounds of additional gear strapped on just before they boarded the plane. So explain why this surprise would be a problem using the law of conservation of energy. A big problem. Okay, your next question. This is question number 3. On the left, you see a mammal, 98.5 degrees or 37 degrees Celsius. That's its body temperature. And on the right, you see a Gila monster. Its body temperature is going to be whatever it is that day. So here's your question. Question number 3. And you have, oops. Let me go to the previous slide if I can. There we go. You have 3 options. Option number 1, what is each animal's main source of thermal energy? So you can answer that question. Option number 2, by the way, that they're different. Okay, so for option number 1, one has one source of thermal energy, the other one has a different source. Option number 2, explain why the kangaroo must take in 20 times as many calories as the Gila monster using the law of conservation of energy. It's got you don't have to do any math there, but you have to explain why it would need an awful lot more food using the law of conservation of energy. Option number 3, use the law of conservation of energy to explain why exothermic or cold-blooded animals have advantages and also have disadvantages, and endothermic, warm-blooded animals have advantages and disadvantages. So there's goods in both and bads in both. So what are the advantages and disadvantages? Use the law of conservation of energy to explain that. Next question. As you can see, this guy on the right, the anvil is about 1 meter closer, and here's your question. Why does the anvil on the left have more joules of potential energy? That's for option number 1. Option number 2, what are the main 2 components that will increase an object's potential energy? There's 2 things that increase an object's potential energy. Option number 3, explain why the anvil's kinetic energy must increase as its potential energy decreases. So those are your 3 choices for question number 4. And we're almost done. Okay, next question. What source of chemical and potential energy does a car need? Option number 2, explain what the gasoline-powered combustible engine converts its chemical energy into. What other forms of energy? And option number 3, use the law of conservation of energy to explain why the gas-powered combustible engine is considered by many people to be highly inefficient. Highly inefficient, okay? So those are your questions. And this is some instructions, okay? So answer those 5 questions, numbering 1 through 5 on a Google Sheet, and share your answers with Mr. Flugum, Mr. Marquis, or Mr. Olaf, depending on who your teacher is.
Robbie, look at this one. Notice something? It's Mojang. A golden apple. Or not apple. Robbie, have you seen Star Wars? Okay, good. This show will connect you. Hey, Robbie.
Hope you guys are being safe. I hope everybody's having a good April. I think Mr. Marquis, Mr. Flugum, and I, we miss interacting with you guys. Miss seeing you guys on a daily basis. And but anyway, I didn't expect to finish the year teaching this way, but we'll make do. And I hope you guys can get something out of this. So, looking forward to seeing kids again next year. Thank you, guys.
Marmar in the pen.